In this video, we will discuss a Python program to find all prime numbers between 1 to 100. So there are two approaches to solve this program. Let's discuss the first approach. So I have copied this code on the com- in, copied the code and executed. So we are getting all the prime numbers from 1 to 100. So I will explain the logic of this code. Basically, what we are doing is we are checking the number is divisible means yeah, I will explain you the logic. What is a prime number? A prime number is a number which is divisible by 1 and itself. So here double star means exponential operator in Python. So here we have range 2 to, let's consider number 100 as an example. Square root of 100 is 10. So as you see in our code, our range is from 2 to square root of n plus 1, means in this case 2 to square root of n means square root of 100 is 10 plus 1 11. So for this range values will be from 2 to 10. So if I have to divide I have to divide 100 with all these values from 2 to 10. 100 divided by 2, 100 divided by 3, 100 divided by 4. Here, here remainder is 0, here remainder is 1, here remainder is 0, here remainder is 0. So for a number to be prime number, if any of the number is divisible by one of its divisors up to square root of n, then it is not a prime number. So if any of these 10 numbers give us remainder 0, then it is not a prime number. If we don't have remainder as a we don't have remainder as a 0, then it is a prime number. So in this case we encounter more than two zeros as a remainder, so this number is not a prime number. As prime number, it is a number which is divisible by 1 and itself. So if for any of these 10 divisions we get remainder as a 0, then it is not a prime number. If for any of the case, if we get remainder of other than 0 for all these 10 number, then it is a prime number. So this was a example of non-prime number. I will show you the example of prime number now. So as you see, we will take example of 17 here as a prime number. So 17, what is square root of 17? Square root of 17 is approximately 4 point something, right? 4 point something, 4.1 some, 4.1 something, right? So we have to divide this 17 by, so here range is from 2 to square root of n plus 1, which is 4 plus 1 5. We have to divide by 2. Here remainder is 1, here remainder is 2, here remainder is 1, here remainder is 2. So in none of the case remainder was 0. So if, if you get remainder as 0, number is for any of the case, or any of division, division number is not prime number. As you see, this is a prime number as we don't get 0 of any for any of the case here. We didn't get 0, so it is a prime number. If a number is, if we get if a number if any of the divisor divide the number by 8, then it is not a prime number. Our second approach. So this approach is using division divisor count method. So as you see, we got the same output which was that of approach 1. So basically what we are doing here is we are counting the counting the counting here count variable, which will tell us if the if if the number is divisible by its own own numbers in the range 1 to n plus 1. So here we'll take one example. Let's take example of 19 here. Now here count is 0, right? here I is in range 1 to n plus 1, which is 19 plus 1, 20. So our values will be from 1 to 19. Now we have to check whether 19 is divided by all these values. 1, 19 by 2, 19 by 3. As you see here, it will not give us remainder 0. It will give us remainder 1. Here it will give remainder 0. Yeah, 0 it will give remainder. Here it will give remainder 1. Here it will give, here also it will give remainder 1. So whenever we get remainder 1, we have to, whenever we get remainder 0, we have to increase the count. Here we will get remainder 1. For last 19 divided by 19, we will get remainder as 0. So whenever remainder is 0, we increment our count. Here count will be 0 plus 1, 1. Here count will be 1 plus 1, 2. So whenever we get count value as 2, that number will be prime number. So let's now take example of non-prime number. Let's take off, let's take off 50 we will take. Range will be 1 to 51. Numbers will be 1 to 50. Now we have to divide 50 with all these numbers. As you can see, whenever a number is divisible by 50, we will increment the count. So here 1 is divisible by 50, so count will become 1. Here 50 is divisible by 2, so count will become 2. 50 is not divisible by 3, so count will remain 2 only. 50 is not divisible by 4, count will, 50 is divisible by 5, so count will become 3. Here count is greater than 2. So for a number to be prime number, count should be equal to 2. Then only it is a prime number. So 50 is not a prime number because here count is exceeding 2, more than 2 num- numbers are dividing 50, so it is not a prime number. Where in the case of 19, it was only 1 and 19 were the numbers which were able to divide the number 19, so it was a prime number. Other numbers from 2 to 18 were unable to divide 19, so count was only 2 in this case, so it was prime number. Whereas in this case, count exceeded 2, so we did not need to check further values. From 6 to 50 we did not need to check. So this is how prime number works. Hope you